Hello friends, welcome back to your UPSC. So today we'll start with our another topic of geomorphology, that is continental drift. So let's get started. So the continental drift theory was given by F.P. Taylor and Alfred Wegener. So first we will study the theory of Alfred Wegener. First we'll study the theory of F.P. Taylor. F.P. Taylor postulated the concept of horizontal displacement of continents. Okay, so he said that the continents have displaced horizontally. So what was the aim of F.P. Taylor? He actually wanted to explain the distribution pattern of tertiary folded mountains. Okay, so actually till that time we had contractionary theory. It said that uh, Earth was a hot body. Initially it was a hot body and it gradually cooled down. Okay, so it gradually cooled down, and due to cooling it contracted, and due to contraction there were many folds in the earth. These folds were formed mountains. Okay, but he did not find any help in this from this contractionary theory, so he decided to propound another theory, that is drift or displacement theory. Okay, so so to explain this pattern of tertiary folded mountain, he actually propounded this drift displacement theory. Okay, in this theory he started from the Cretaceous period. Okay, he did not explain anything about pre-Cretaceous period. Okay, so he said that there were two land masses. Okay, initially there were two land masses, that is Laurasia and Gondwana landmass. So Laurasia was located at the North Pole. Okay, so Laurasia was located at the North Pole and Gondwana was located at the South Pole, respectively. Okay, and the continents were made of Sial. So these continents were made of Sial, okay, silica and aluminium, Sial, and they were moving towards the equator. So these are the two land masses. Okay, they are made up of Sial. Okay, so they are made up of Sial and they are moving towards the equator. And what is the force that is moving them towards the equator? So the force that is moving them towards the equator is the tidal force of moon. Okay, they are actually experiencing two movements. First is equatorwards movement and the second one is westward movement. Okay, so they are moving like this. Now because they are moving, the land masses are experiencing stretching, splitting and rupture. Okay, so these land masses are, first they are stretching and they are splitting apart, and they are combining with the other landmass and rupturing with other land masses. Okay, so because they are rupturing with other land masses, they experience fold, and this fold forms folded mountains. Okay, and by this movement, this whole thing, they are forming the present day landforms. Okay, this whole rupturing, splitting and stretching will lead to formation of present day landforms. So actually what is the process that is happening is Laurasia is moving away from North Pole. ठीक है? It is moving away from North Pole because of high enormous tidal force of moon, and it is moving towards the equator. And because of this movement, there is stretching, splitting, and rupture of landmass. Consequently, because of this, various landforms various areas like Baffin Bay, Labrador Sea, Davis Straits were formed. Okay. Similarly, the displacement of Gondwana land. Okay. So Gondwana land is also displacing away from. It is moving away from South Pole and moving towards the equator. And because of this, Great Australian Bight, Ross Sea are formed. Okay. And the Arctic Sea was formed between Greenland and Siberia. Okay, Arctic Sea was formed between Greenland and Siberia due to equatorward movement of Laurasia. So, Arctic Sea was formed. Okay, and then later after the drifting, the area, see that these two land masses have drifted away from each other. Okay, they have drifted away. So, this area, this gap was filled by water. So that is how this whole thing happened and the present day continents were formed. Okay. Now, what was the criticism of F.P. Taylor? The first criticism was he actually moved continents for to a very long distance. Okay, like thousands of kilometers. He moved the continents to thousands of kilometers. Okay, but for the formation of mountain, if the continents would have moved to 34 or like this much kilometer, 32 to 64 kilometers, this would have been enough. Okay, but he actually moved them to great lot of distance. Then the second problem was if the tidal force of moon would have been so strong that it could have drifted the continents, then the earth would have stopped within a year. Okay, but this is not the case. So the force of the moon can't be that strong, okay, to drift the continents. So that was the whole theory of F.B. Taylor. Now let us jump to the next theory. So we have the next theory of Alfred Wegener. He gave his concept in the book that is known as Die Entstehung der Kontinent and Ozean. He actually gave his theory in 1912. Okay, but when he it gave this concept again in 1922 in his book, this book in 1922, it gained light. Okay, it came into light and it became famous in 1924 when it was translated into English. Okay, so actually what happened was Wagner was just a second. Wagner was actually working with various scientists like geologists and climatologists, planetologists, geophysicists, etc. And he found that there is there are many similarity or there are ample evidences that the climate of the areas have changed throughout the time. Okay, throughout the past history of the earth, the climatic condition of the specific area has changed. Okay, so what he wanted to he wanted an explanation. Okay, he wanted the explanation that how can such a major variation in climate occur. Okay, so he actually took two explanations. Okay, he took two explanations. The first explanation was either the continents were stationary, like they were at their place only, and the climatic zones would have shifted, but this can't happen. Okay, so he moved on to second explanation, that was that the climate zones were as it is, and the land masses must have moved from one place to another. So he went with the second explanation. Okay, so what were the basic premises of the theory? He actually formed some basic premises in which he said that, to explain his theory, he said that there is a Cialic layer and there is Sima layer. Okay, so the Cial forms continent, and Sima, the upper Sima, forms the bed of the ocean or oceanic crust. Okay, and the Sima, sorry, the continents are moving over Sima. Okay, floating over Sima without any resistance. Okay, he started his theory from Carboniferous era, but he actually started his theory from Carboniferous era because he found evidences of glaciation of the rocks from that era only. But it is not that it is not such case that he did not believed in pre-Carboniferous drifting. Okay, he believed in that, but he actually started his theory from Carboniferous period. So what he said that initially there was only one landmass, that is Pangaea. It was surrounded by a huge water body, that is Panthalassa. This Pangaea was later on divided into two landmasses, that was Laurasia and Gondwana land. Laurasia land, he also called it as Angara land, and the southern one was Gondwana land. He called it as, he did not renamed it. Okay, so Laurasia or Angara land was consisting of North America, Europe, and Asia, and the other areas like Africa, South America, Antarctica, India, okay, um, Australia, etc., were the part of Gondwana land. Okay, and the Pangea was disrupted. Okay, this Pangea was disrupted to form present-day continents. Okay, this Pangea was disrupted to form present-day continents. He gave various evidences in favor of his theory. So these evidences are, first is the jigsaw fit. Okay, so he said that this is our South America, this is our Africa. Okay, he said that these two land masses, these two opposite coasts of Atlantic Ocean, they can actually fit with each other if they are brought closer, which gives us the evidence that they were, at some point of time in past history, they were one landmass. Okay, next is, he said that he proved that actually that Caledonian and Har- Hyrcanian mountain system of west and east coastal area of Atlantic are similar and identical. Okay, their rock structure was similar. Okay, next, both the coast of Atlantic are identical. as they are having similar fossils, similar rock structures, similar flora. So these two, both the coasts are identical. Next is lemming. Lemming is actually a small animal. He said that it migrates westward from North Scandinavia, but it drowns in the sea as there is no further land beyond that area. Okay, so he moves westward, okay, and he drowns. So this movement or this habit of theirs, it it proves that in the past, somewhere in the past, they had the tendency to migrate far west, okay, okay, when the land, when there was land in this area, okay. So that means the land must have gone somewhere from here. So this was also a evidence in favor of his theory. Next is there is a Glassopatris flora. Okay, it is found in India, South Africa, Australia, Antarctica, Falkland. Okay, so these land masses are very far apart from each other, but they have similar type of flora, which proves that they were united at some point of time in the past. Same is the case with Carboniferous glaciation period. Carboniferous glaciation is found in the evidences of Carboniferous glaciation are found in Brazil, South Africa, Australia, Falkland, and Indian Peninsular region, as well as in Antarctica. So this also proves that they were at some point of time in past they were united as one. So after giving the evidences in favor of his theory, he described the process of the theory. So in this process, he said that there were two types of movement in Pangea, that is equatorward movement and westward movement. This equatorward movement was due to gravitational force, gravitational differential forces and the force of buoyancy. Why the force of buoyancy? Because Sial was floating over Sima. Okay. Actually, these forces they are actually opposite of each other, but because of the shape of the Earth, that is ellipsoidal shape of the Earth, there is no direct opposition. Okay. So due to gravitational differential force and force of buoyancy, there was equatorward movement, and the westward movement was caused due to tidal force of sun and moon, which was maximum at the time when the moon was nearest to the earth. Okay, so when the moon was nearest to the earth, there was maximum force. Now, how the actual drifting of these continents took place. So, initially the Pangea, we had Pangea, it was broken into two, that is Laurasia and Gondwana. So Laurasia or Angara land, and this is Gondwana land. And between these two, there was a resultant water body. Okay, there was a resultant water body known as Tethys Sea. And when there was the Pangea was disrupting, this phase was known as opening of Tethys Sea. Okay. Now, these two land masses they further disrupted, and because of this disruption, there was splitting, stretching, and rupturing of the land masses. Okay, what actually happened was Gondwana land was disrupted during Cretaceous period. Okay, and Indian Peninsula, Madagascar, Australia, and Antarctica were broken away from Pangaea and drifted apart under the impact of tidal force from Sun and Moon. Okay, so in Cretaceous period, India, Australia, Madagascar, and Antarctica were broken away from Pangaea and drifted. Okay, and then North America was broken away. Okay, North America was broken away from Angara land and drifted westward due to tidal force. Similarly, South America from broke away from Gondwana land and moved westward. Okay. Now the Indian plate was moving in northward direction. Okay. Indian peninsula was moving in northward direction, and due to this movement of Indian peninsula in northward direction, Indian Ocean was formed, while Atlantic Ocean was formed due to westward movement of the two Americas. Okay. Now from here and from here they are moving, and this area which is being separated, so this area which is being separated is forming Atlantic Ocean. And here, because India is moving, Indian Ocean is being formed. Okay. And this was of ash shape. Atlantic Ocean was of ash shaped. Okay. Now, Antarctic and North Sea were formed due to why and Antarctic sorry Atlantic Ocean is formed. Now, Arctic and North Sea were formed due to flight of continental block from North Pole. Now, from North Pole, these these continental masses they moved. Okay, because of which Arctic and North Sea were formed. Okay, now because of this movement of the land masses, the size of the Panthalassa, that is the huge water body, it actually contracted, or it actually looked smaller. Why? Because the land masses were now like this. Okay, whatever. So now the land masses were like this. So the water body was seemingly smaller. Okay. Now this rupture continued from Cretaceous period to Carboniferous period to Paleocene period, and it is continuing till now. Okay. Now, how the mountains were formed during this process. Now, this is actually a drawback of Wegener. He said that when the frontal edges of westward drifting continental block were crumpled and folded. Okay, they were moving westward. See, this landmass is moving westward. So this is being crumpled and folded. Why? Because of resistance of rock of sea floor. Okay, because of the resistance from sea floor, that is SEMA, the the crumpling is happening, and this crumpling is forming the folded mountains. But now the criticism is that firstly he was saying that this Sial is moving over Sima, is floating over Sima without any resistance. Then how can the Sial crumple? Okay, so he was not able to explain this thing, and because of this, the theory failed. Next is island arc. So in this island arc, he said that the whole landmass, it was moving westward, and the land masses which were not able to keep in pace, okay, keep in pace with this landmass, they were left out. Okay, they lagged behind, and this lag behind land masses they formed island arc and festoons. And this is how the festoons consisting of Japan, Philippines, etc. were formed. And similarly, in some portion of North America and South America, while they were moving westward, some island arcs were formed. Okay, like, and in Australia also, various things were formed. Now, next is Carboniferous glaciation. So, in Carboniferous glaciation, there were ample evidences to suggest that, or to prove that there was a large scale glaciation during the Carboniferous period, and the land masses like Brazil, Falkland, South Africa, Peninsula India, Australia, Antarctica, etc., they were extensively glaciated. Okay, and the pattern of glaciation and the flora and fauna, or the rock structure, whatever was found, it was having same characteristics in all these land masses. All these land masses were having same characteristics, which proved that these land masses were united during this period, and later on they were drifted apart. Now, this is the whole process of this theory, continental drift theory. Now, evaluation of the theory. Actually, this theory had many criticism because the Wagner was not able to explain many things. Like, first thing was the forces. He actually said that the forces like buoyancy force. Next is gravitational gravitational frictional gravitational differential force, buoyancy force, and tidal force. Tidal force of sun and moon. Okay, so these forces are not sufficient for drifting a landmass. Okay, next is, we have studied that there was confusion in the relation of Sial and Sima. Firstly, he was saying that the Sial is floating over Sima. Nextly, he was saying without any resistance, and the cause of formation that he explained, for the cause of formation of folded mountain, he said that the Sial was crumpled because of friction force, or the resistance force applied by Sima. Okay, so this caused the confusion. Okay, and the next thing is that Sial or Sima is not so strong that it can crumple Sial. Okay, and another thing is that Sima is much, much denser than Sial, that Sial cannot float over Sima. The another criticism was that he did not elaborate the direction, chronological sequence, and of displacement of continents. Okay, and he did not even describe the situation of Precambrian time. So that was the whole evaluation, or sorry, the criticism of this theory. But this theory has its own importance, as it was a step forward, and it was a step forward in this precarious field. Okay, and this step led to the formation of various modern theories of present time, to give the evidences of how actually our continents came into existence. Okay, so that was all for uh, all in this continental drift theory. So that was all for today, guys. I hope you enjoyed the lecture. So let's meet in our next class. Till then, take care and have a nice day.